Alright, so this is project 2 for Dr. Osbe. I'm Nicole Rangel, and I'm going to be showing the flow simulation of airflow over a flat plate. So first we're going to click here, flow fluent. We're going to click geometry. Let's make sure it's 2D. Then we're going to right click new designer model or geometry. Then we're going to wait for that to open. We're going to click Z-axis for the X and Y plane. Click here, X and Y plane, sketch. Let's zoom in a little since we're in meters, our dimensions are going to be smaller. Let's click rectangle, draw our rectangle. We're going to dimension it. It's 100 centimeters, so the height is going to be 1 meter. Our length will be 1 meter. Sorry about that. Our height will be 5 times our boundary layer, which our boundary layer was 0.0136931. So 5 times that gives our height, which is going to be 0.06844653, which that gives us our height. So this is what it should look like. Let's do a little proper zoom in. Perfect. So then we're gonna go to modeling. We can make sure our sketch is selected. Let's go to concept, surfaces from sketches, apply, generate. So here we generated our geometry, and this is all done for this portion. Then we're going to go back to the workbench. We are going to press mesh. We're going to wait for that to open. Alright, so now that it's opened, we're going to go over here to mesh. We're going to insert a face mesh. And we're going to select, we're going to apply. So that's going to be our face mesh. We can press generate. Let's check out and what the freak. This is how our face meshing should look like. Yeah. So then we're going to add some sizing to it. We're going to insert sizing. We're going to select the edges here, hold control and select the top and bottom and click apply. Element size, we're going to change it to number of divisions. We can do 50 number of divisions. Curvature, we're going to say no. And we're going to change soft to hard. Perfect. And then, yeah, we're going to press generate. Perfect. Let's check out what that looks like. Okay, this came out pretty good. We're going to do another sizing, and it's going to be just this inlet right here. We're going to press apply. We're going to do element size is going to be number of divisions. Here our number of divisions can be a little higher, so 60. Curvature, same thing, no. Hard will be, soft will be hard. Perfect. Here we're going to do bias. We're going to change no bias to the first option, and then we're going to do the bias factor of, alright, so for the bias factor we'll put 70. Let's zoom in here. Let's zoom in here. So the nodes get smaller at the bottom, which makes sense because this is our plate, and then it gets less concentrated through the top. So it makes sense, and let's generate, and we can check out the mesh. Let's zoom out. Okay, after you did the left side, we're gonna go right ahead and do the other side. Mesh, apply. We're going to change type to number of divisions again. Same thing, 60. No to curvature. We're going to change soft to hard. Bias will be the same thing. factor will be 70. Let's zoom in. Let's zoom in a little. Now, here you can see that it's more concentrated on the top than the bottom. So let's make it the same as the left side. First, we're going to click the edge. We're going to apply the reverse bias. So now we can see that it's concentrated more on the bottom. So it matches the left side. We're going to click generate. We're going to take a look at our mesh and it looks good. Okay, so here we're going to name our flow. It's going to be, just press N. We're going to do, the whole thing is going just to be airflow. And then, perfect. And then the other section, let's go to edges. This, the left side, press N. We're going to do inlet. And then press N, the right side. We're going to do outlets. And then the bottom, press N. That's going to be our plate. And then the top, press N. That's just going to be the top of our control volume, so it's not really anything. We can just put, we can put something like field of pressure. Perfect. Now we can look at all of our named sections, make sure everything's right. Airflow, inlet, outlet, plate, field of pressure. Okay, perfect. That looks good. So now we're going to go to, we're going to go back to Workbench. We're going to update. Then we're going to open setup, double precision, start. Perfect. Let's make that big. All right. So here we have our inlet, outlet, where it's more concentrated in green is our plate. And yeah. So first we're gonna go to models. We're gonna change viscous to laminar. Perfect. We can close that, and then we're gonna go to boundary layer conditions. This is where the project comes into play. So ours was the velocity in the project at 2 miles per second. Close. Alright, so then we're gonna go to field of pressure. We're gonna do specified shear 0, 0 because that is nothing important that we need to take into consideration. So that's just the end of our control volume, but we don't need that. So we're just going to press apply, close. Inlet, I already changed that. Outlet, everything should be normal. And we can check the plate, make sure it's stationary, non-slip, yep, that looks fine. And then for materials, we're gonna double click on air and change the air density to 1.2 as specified in the project. Changing gray, close. Okay, so from here we're gonna go to, right, I forgot, when we're going to air, we're going to also change this to 1.8 as specified in the project. So we're just gonna make sure we have that right also. And then we're going to go to initialization. Initialize. We're going to go to run calculation. We're going to number of iterations would be. Alright, so before we actually run this calculation, we're going to go to monitors, residuals, just so we make it a little bit more specific. So after residuals, we're going to go here. Let's edit 500. Let's do 1,000, just so we have more precise locations. We're going to go here. We can initialize and calculate. Here. Okay, so here we can see, interesting, calculate velocity in respect to iterations. Okay, so here, after that, after the calculations, we're going to go to, first we can go to contours. Hello, okay. We can check out our static pressure. This is what it would look like, which makes sense. It's highest at the inlet, and as it goes out, it's less pressure. So take a screenshot, put this in your report, close, and then after this, we can get our velocity vectors. Let's go to scene. Let's go vectors, velocity magnitude, plate, save and display. Perfect. Velocity magnitude with the vectors. The plate should end right here at this orange, and then it makes sense because as it goes in, velocity is the highest. It's not being constrained by anything or by the plate. So this is our velocity vector. Oh, sorry, velocity vector contour. So take a screenshot, put it in your project, and then the next part will be to get the plots. Alright, so we're going to go back to get our plots. We're going to update everything, everything's updated. We're going to go to results. And here is where we are going to get our plots. Alright, so here we're going to add a line. Okay. We can do 100 samples. Our line is going to be from 0.25, 0.25. This will be, and this can be 0.1. Since the height was 0.06, we can just leave it at 0.1. And then we can put this to 100. We're gonna go click apply. Okay, we can actually put the height then. 0.6853. Hit apply. Perfect. Let's create another line. Okay, this one you can let it right. Okay. This one can be 50. 50 centimeters. Which this is gonna be 0.5 meters. 0.5 meters. Here, same thing, 0.684653. Let's just copy this so it's easier next time. 0 here, I'm at 100, we're going to apply. And then our last line, which is x 75 centimeters, which that's going to be 0.75, that's going to be 0.75, and here is going to be our height. That's 100 samples, apply. Perfect. So now we have 0.5, 0.25 meters, 0.5 meters, and 0.75 meters as our three lines, as stated in the project. Here, we're going to add chart. We're gonna go to data series. We're gonna do Same thing as we did for the lines. X equals 25 centimeters. This one will be X equals 50 centimeters. X equals 75 centimeters. Perfect. So then we're gonna go to, let's title this. This is gonna be our velocity profiles graph. Data series. We don't need this one. Yeah, these are all the ones we need. We can click a plot, edit. We can do line 1. We didn't name that one. Line 2. And line 3. Perfect. Let's click apply. Oh, we didn't do X and a Y. Okay, wait. And then after here, sorry, I accidentally clicked apply. We're gonna go to, for the x-axis, we want velocity, and y-axis, we want y. There you go. So, velocity profiles should look like this. Screenshot, put it in the Word doc. Alright, so now for the other plots, we're going to go back to Affluent right here, and we're going to go to XY plots. Under plots, we're going to open this. First, we're going to get the shear wall stress. We click wall flexes, shear wall. We can choose plate. This is where you would take a screenshot, put it in your Word doc. Write to file, we can also do order points. Write to file is where you would take this and put it in your Excel file to compare with the theoretical. And then to get the skin friction coefficient, we're going to go to wall shear stress, skin friction coefficient, plate, selected, perfect. They both look relatively the same, makes sense. Here you would also write to file, import it into your Excel, compare with the theoretical. Alright, and then to get the total drag force, we can close this. We can go down to reports, forces. We're going to click plate, print. And this total right here is the drag coefficient. Just take a screenshot of this, put it in the Word document or Excel as Dr. Osbate requested. Compare this with theoretical values, and I believe this is it for the project. Yeah, thanks.